Here's problem 3025. Two long straight wires carry currents perpendicular to the xy plane. One carries a current of 50 amps and passes through the point x equals 5 centimeters on the x-axis. The second wire has a current of 80 amps and passes through the point y equals 4 centimeters on the y-axis. What's the magnitude of the resulting magnetic field at the origin? Alright, so let's take a look at what we have here. Here's x, here's y, and at x equals 5 centimeters, 1, 2, 3, 4, 5, we have a current. Let's have it going out of the page towards you, and we're told that that current is 50 amps. And then at y equals 4 centimeters, we have another current in the same direction. We'll have it coming out of the page towards you, and that current is 80 amps. And we want to find the magnetic field at the origin. So that's our point P right there. Alright, if we look at the first current, we're going to have a magnetic field going circularly around it, and if I point my thumb in the direction out of the page, then the magnetic field is actually going to be going counterclockwise like this around that first. So it's going this way around that wire, and in particular at the origin it's going to be tangent to that circle, and it'll be headed in a down direction like this. And if I look at the second wire, it also is going to have a magnetic field going circularly counterclockwise around it with a radius of 4 centimeters, at least to the origin. And in particular, at the origin, it's going to be tangent at that point, going to the right in the x direction like that. That actually would be B2. Alright, so we're going to have these two magnetic fields at the origin that are perpendicular to one another, and we need to find the magnitude of each. So B1 is equal to mu naught I1 over 2 pi R1, and that will be 4 pi times 10 to the minus 7 times 50 amps over 2 pi, and then we are 5 centimeters, 0.05 meters away, and that is equal to what? 2 times 10 to the minus 4 Tesla. And as we've indicated, that magnetic field is going down in the y direction like that. Alright, our second magnetic field is mu naught I2 over 2 pi R2, and that's equal to 4 pi times 10 to the minus 7 times 80 amps over 2 pi times 4 centimeters, 0.04, and that is equal to 4 times 10 to the minus 4 Tesla, and as we indicate, that is going in the positive x direction. So these two magnetic fields are in perpendicular directions to one another. So our net magnetic field at point P is going to be the vector sum of these two, and we're going to have 4 squared plus 2 squared square root times 10 to the minus 4 Tesla, and that is equal to the square root of 20, which is 4.47, times 10 to the minus 4 Tesla, and it'll be going down at an angle like that from the origin. So if we write this in terms of microtesla, that would be 447 microtesla would be the magnitude of the magnetic field, resulting magnetic field at the origin, going down at an angle like this, 447 microtesla.